So this is a heating curve for water. And this is showing the whole range. So here we're starting with ice at minus 25 degrees Celsius, and we can look at what happens when we add energy. The temperature goes up. So here this is ice warming up, and here we're talking about 1 mole of, well, if we're talking, never mind. It would take 0.941 kilojoules for this amount of water to warm from minus 25 to 0. We can calculate this, the heat involved here, using Q equals mc delta T. So use that there. Here we've got the temperature flattening out. This is where the ice is melting. And this relationship is described with the heat of vaporization. So here we've got delta H, not fusion, heat of fusion, the heat of fusion. So if we know how many moles of ice we have, we can use the heat of fusion to calculate the amount of energy needed to melt that. Once it all melts, the temperature will start to go up again. Here along line segment 3, we have liquid water. And if we want to calculate how much energy we need to go from 0 degrees to 100 degrees, again, we're going to use Q equals mc delta T. We're going to use a different heat capacity, though. We're going to use the one for liquid water, not the one for solid. Up here, we have another flat place, and this is where the water is boiling. It's going from liquid to gas, and here it's heat of vaporization. Allows us to calculate the amount of energy needed. Once all of it turns into a gas, the temperature will go up again, and then this again is going to be Q equals mc delta T. So we need to be able to do problems where we give you some substance at a temperature, and then they say, well, how much energy is needed to take it to this other temperature? So this graph would be answering the question, from minus 25 degrees to 125 degrees for water, how much energy is that going to take? And you have to do a different calculation for each line segment. So you do a calculation here, how much to heat the ice to the melting point. And then you do another calculation, how much to melt the ice. And a third calculation, how much to heat the water from the melting point to the boiling point. And then another calculation, how much energy to vaporize all of that. Sorry, I'm having trouble with my